Hi friend, this is Shomik Biswas. You are attending my classes of circuit theory, and before going to the deeper of this today topic, I would like to tell you something before this, that in the previous class I discussed the basic power relations of the AC circuit. Now in today's class I will discuss the analysis of the three-phase circuit. So we can put a name, that is analysis of three-phase circuit. So one three-phase circuit is what? Suppose this is a sine wave, it is passing. So what is the phase? That phase is 0. So suppose that is 90, that is 120, that is 180, that is 270, so that is 240 suppose. So another wave is created which is starting, this is its initial phase, so just like this, and the third one is created as the like of this. So finally the final voltage is created as V summation equals to Vm sin theta plus Vm sin theta minus 120 degree plus Vm sin theta minus 240 degree. So you can consider the sine component, but in our system we should consider that the cos component. Why? Because we always doing real power calculation, so there the AC circuit, when the three phase can be considered, it is better to have some cos component. So we better write that is Vm cos theta plus Vm cos 120 degree minus theta plus Vm cos 120 degree plus theta. So these three phase, okay, so three phase are applied as a summation in a particular load. So what happened, and that is the analysis of the three phase circuit. So it is a phase 1, we should write that is phase 1, that is phase 2, and that is phase 3. So these three phase are applying in a particular RC, RL or any sort of load. Then what happened actually? So before going to this more deeper of that, I'd like to say that the currents that delivered in that network or the circuit, whatever you can say, that may be connected either in that star or in that delta. So before going to the delta, I would like to say something on that star. So how it connect that 1, here it is 2, here it is 3. So that is phase 1, that is phase 2, that is phase 3. So we are applying in that three phase, right, in this way. Okay, so what is the, if this one is called that VR, it is VY, and if it is VB, so what is the gap between these two phases? So you know that VR minus VB, if you want to calculate, so it is V cos 120 degree minus theta minus V cos theta. So it is V, and that is cos minus cos, it is 2 cos cos, so it is 2 cos 120 degree into cos, that is 120 degree minus theta, so it is 2 cancel out, so it is 60 degree minus theta, and that is V, so it is minus half. Cos 120 degree is minus half, so it is cancelled out. Cos of 60 degree minus theta. So this angle between is 60 degree. So if you are adding this vector summation, if you are adding this, or if you are finding out the result, so it should be V of Ry equals to V square R V square y for Ry if you are taking, plus 2VR Vy cos of theta. Here it is 60 degree. So finally VR, Vy and Vb, all these are equal. So VR equals to Vb equals to Vy equals to V phase. Okay, so finally it is root over 3 V phase Vry. Okay, so that is root 3 V phase. Now that V phase and Vry means that is Vry, and what is V phase? So Vry and V phase, what is the distance? Because Vry, if you are making this, if it is Vry and if it is V phase, so what is the angle in between this? That is 30 degree. Why? Because you know that Vph by Vry equals to 1 by root 3 equals to tan 30 degree. So therefore the angle is 30 degree. And if the line current is like this for VR, if it is IR, so the angle between that, if it is VR, so the angle is basically phi. So what is the angle between Vry and IR? This is 30 degree plus phi. Okay. So in this way, what is the basic analysis, what is the basic assumption you can grow from this, that in that star connected load, that Vry, it means that difference of that phase voltages, sorry, difference of this VR minus VB, this is the line voltages, that is equals to root 3 of that phase voltages. So everywhere it is same, but that load current IL equals to IPH, the phase current, and it is same as IL sin theta. But instead of this, if you are connecting these things in a delta connected load like this, so what happened then? Here one phase, here one phase, and here one phase, we can connect it. So the three phase is connected in this way in a delta connected load. So in this way you can see that Vry equals to V line, but IRY equals to root 3 IPH. In the same way you can calculate it, and easy to get this particular answer. So next we should study about in short of the measurement. So if you are doing short of wattmeter measurement, so if you are putting some wattmeter in a star connected load, say suppose it is a star connected load, and you are placing some wattmeter, as the first wattmeter is there, you are connecting one wattmeter with reference to that ground, and the second wattmeter is again connected with reference to ground. That is a complete circuit. So we can say that the wattmeter reading W1 for this is what? Vi cos phi. So here phi is what I have shown, that is 30 degree plus phi. So it is Vi cos 30 degree plus phi. V1 I1 we should write in this way. So what is omega 2? That is the same way, that is you can say that is V2 I2 cos of 30 degree minus phi for this. So what is V1? V1 means this with that reference of VR. So I can write it as VROI IR. Okay, this V1 can be written as VROI for this, and that is why. So it is VROI. So the second one is this. So what is W1 plus W2? If you are adding them up, so it should be VI here, V into I here into root 3 into cos phi. So it is root 3 Vi cos phi. Now if you are doing, that is W1 minus W2, it is only Vi cos phi. So what is that? Tan phi equals to root 3, that is root 3 into that is root 3 into W1 minus W2 divided by W1 plus W2. So this phi is called the power factor. Now using this 2 wattmeter method, you can easily determine what is the power factor of the circuit, and using this power factor you can calculate that wasted load or the power loss in this particular circuit analysis. Now here one thing in short I have to say, that what is unbalanced load. Here if any sort of 3-phase circuit, the connection either star or delta, but the load should be identical to each other. But if there is some violation of this identical rule, it means in some branches if the load is increased, so obviously the neutral point means this end point, it never have that no current, so must be some current flowing to that neutral point. So this is called the unbalanced load. If you are having the unbalanced load, the phase voltage can never be equal, so obviously the neutral have some floating current flow, so it has to be corrected out, otherwise the big devastation may take place. So we should have some mathematical examples. So I have jotted down 2 problems for you. So the first problem, that is given that 3 points are given, so 3 phases are declared, and it is given that the power supply, that is 100 volt 50 hertz. There is a power supply, so this is 100 volt, this is 100 volt plus 120 degree, this 2, and this to this is 100 volt minus of 120 degree. So the 3-phase current, 3-phase voltage is applied to this, and finally we have to find out the phase current and phase voltage. So here it is a delta connected load, so that phase current is basically that having relation with that IL equals to root 3 PH, root 3 IPH, the phase current, but that V phase equals to V line to line voltage. Okay, so here what is I phase? That is V phase. V phase is here. What is I phase? For that I phase of RY, if you are saying that is R, that is Y, that is B, So IPH for RY, if we are doing this, so IRY means the voltage RY. Here these 2 points the voltage is his, so these 2 points the voltage is 120 degree minus. So actually we have to do that RY, here the voltage is given as 0 degree, so I can write it 100 angle of 0 degree by 6 plus J8, so equals to 10, the angle of minus 53.13 degree. Okay, so in this way you have to find out that IPH YB. So what is IPH for YB? In the same way it can be calculated out, that is 10 with that angle of minus 173.13 degree. So in this way you can easily calculate IPH for BR, and that is like this. So finally the line current is IL equals to √3 of IPH. So you have to keep this modulus value, so it should be √3, and that IPH is basically, the mod value of IPH is basically 10, so it is √3 into 10, so it is √3 into 10, it means 1.732 into 10, so it is 17.32 ampere. Okay, so that's the one case. In another case you have to find out the same thing and you have to draw the power triangle. So in the same way you can have that, if you want to find out that IRY, so IRY here, IRY, now the same thing, that is RYB, you have to consider that is RY, it is B. So R2Y, so RY, get that R2Y 0 applied, so it is 110 with that angle of 0 degree, that is that voltage, and that impedance is 545, so 5 angle of 45, so it is 22 angle of minus 45 degree. So in the same way that I of YB is what, that is 110 angle of minus 120 degree, YB, Y to B means this is 120 degree, Y to B, this is Y to B, this is plus 120 degree, that is Y, Y is this and this one, so that is minus 120 degree, so it is minus 120 degree, so Y to B is divided by 5 angle of 45 degrees, so it is equals to 22, that is additive, so minus 165 degree, and that similarly you can find out IBR, that is equals to 22 angle of 75 degree. So how to find out that IR? So IR is IRY minus IBR. So what is IR? That is equals to IRY minus IBR. So all the values are there, IRY, IBR, that value is there, so just subtract it, you will be getting it as 38.05 angle of minus 75 degree, just subtracting this one and this one. In the same way you can find out what is IY, that is 38.05 angle of 165 degree. What is IB? That is equals to again 38.05 with that angle of 45 degree. So if you are making this vector diagram, so how it look like, first of all, so here three phase, that is given as VRY, it is VYB, and here it is VBR. So the first current, obviously it is IRY, and it is obviously IYB, and it is obviously IBR. Now this is minus IBR, this is minus IYB, and this is minus IRY. Okay. So here IR means what? That is IR means it is a IRY IBR, so IRY IBR. So here IRY and IBR we are having, this is IB, so this is IB, and the angle ID has made, that is that VRY, so this is we are having, that is 45 degree. In the same way that this IB and this one IBR, if you are making this, so that is the particular one for IR, and that angle of that IR here is 75 degree, that is given minus 75 degree, because we are measuring angle in this way, so that is in this way, so it is minus 75 degree. So the last one is IRY, and this is, so it is IY, and that angle of this one is 165 degree. So this is a vector representation of that entire mathematical problem. Hope you have understood and enjoyed, perhaps. So in the next class we'll go much more deeper of this, and we'll discuss much more things on that Z network in the combination of that image impedance, the combination of that active and passive filter synthesis and analysis. So be there in my next class where I will discuss the filter analysis and synthesis. So thank you very much. Goodbye.